Hello everybody. Today we are going to see about Thevenin's theorem in detail. So this Thevenin's theorem states that a linear two-terminal circuit can be replaced by an equivalent circuit consisting of a voltage source VTH in series with the resistor RTH, where VTH is the open circuit voltage at the terminals and RTH is the input or equivalent resistance when the independent sources are turned off. So if you see this Thevenin's theorem as a whole, you may not be knowing what to do with this Thevenin's theorem. I have separated this theorem into small portions which are actually given here in different colors. So the first one is yellow color, then you have green color, then purple, and then blue. I'll explain all these things in detail. So we'll see them one by one. So we'll see what is the essence of this whole theorem. So you have one circuit and that would be replaced by another equivalent circuit. So you should know what is equivalent. So two circuits will be said to be equivalent if the same voltage current relationship is maintained at the terminals. So you have one big circuit or you have a complex circuit, and that complex circuit will be replaced by another very simple circuit, but that should be an equivalent circuit. So now we'll see the first line that states a linear two terminal circuit. Suppose if we take this circuit, it is consisting of three number of resistors and two sources, independent sources. Anyhow, they have two terminals here, right? See, this is terminal number 1, this A, and this is terminal number 2. So this is one best example for two terminal circuit. Now we'll see what is a linear circuit. Linear circuit is the one which follows the linear relationship. Example, or we say that V is equal to IR. This P is equal to V square by R. That power relationship is not applicable here because it is a linear circuit. So now we have seen the whole definition of this linear two terminal circuit. So now we move on to the second portion. So it would be replaced by an equivalent circuit. That equivalent circuit consisting of a voltage source VTH in series with the resistor RTH. So you have a bigger circuit here, which is a linear two terminal network. It may be a complex one. And here you have a two terminals A and B that may be closed by this load resistance. And you can replace this whole circuit with the help of a Thevenin's equivalent circuit. So that Thevenin's equivalent circuit consists of only one voltage source that is now named as V Thevenin, and only one resistance that is named as R Thevenin. Okay, so at the terminals, that is A and B, you have the load resistance connected, but in this two terminal network portion you have only one voltage source and the resistance. That's it. So we are making the circuit very simple. But actually, how to get this VThevenin or how to get this RThevenin, that is important. Then only we can actually form this circuit. So first step in finding the VThevenin is to remove this load resistance. Then you have to measure the voltage across this terminals. That can be named as VAB, that is equal to VThevenin. Similarly, it can also be called as VOC, open circuit voltage. Why? Because we have opened this resistor. So to find out this VThevenin, we have to remove this load resistance RL, and across this AB terminals, we have to find out the voltage appearing. Okay. Similarly, to find out this RThevenin, after removing this load resistance, we have to look into this circuit, complex circuit, and we have to find out this equivalent resistance after killing all the independent sources. That we have to retain or we have to keep the dependent sources. So how to kill this independent sources? Killing independent sources means making them inactive by replacing all the voltage sources by short circuit and replacing all the current sources by open circuit. That means after killing the independent sources, you have to look into this particular circuit through this AB terminals and find out the R equivalent value. That is called this R Thevenin. Okay. So after finding out this V Thevenin and R Thevenin, you can draw a new circuit or a very simple circuit with the load resistance connected. And in some problems, you may be asked to find out the current, something like this. So you can find out the current here, which is flowing through this load resistance, or you may be asked to find out this load voltage. After finding this equivalent circuit, it is very easy to analyze the load. Okay, so this is what the Thevenin's theorem. So now we Once again, come back to our statement. So it is a linear two-terminal circuit. Any linear two-terminal circuit that can be replaced by an equivalent circuit that consists of VTH and RTH, where VTH is the open circuit voltage at the terminals and RTH is the equivalent resistance at the terminals when the independent sources are turned off. Okay. Hope you have understood this video. Thank you.